In the world of military aviation, few concepts capture the imagination quite like the idea of a next-generation stealth fighter capable of dominating the skies decades into the future. Among the many fictional aircraft that have sparked interest among aviation enthusiasts, the F-22 Phantom Hawk stands out as one of the most intriguing. While not an operational aircraft in the real world, the F-22 Phantom Hawk represents what many people imagine the future of air combat could look like. Combining advanced stealth technology, artificial intelligence, unmatched speed, devastating firepower, and revolutionary battlefield awareness, the Phantom Hawk has become a symbol of futuristic air superiority. Imagine a fighter jet designed not just to survive in the most dangerous combat zones on Earth but to completely control them. The Phantom Hawk is envisioned as an aircraft built for a future where warfare is faster, smarter, and more connected than ever before. Every element of its design focuses on maximizing effectiveness while minimizing vulnerability. Its sleek, angular appearance reflects the principles of advanced stealth engineering. Every surface, every edge, and every curve is optimized to reduce radar visibility and allow the aircraft to slip through heavily defended airspace undetected. One of the most impressive aspects of the Phantom Hawk is its stealth capability. Modern air defenses are becoming increasingly sophisticated, with radar systems capable of tracking targets at greater distances and with higher precision than ever before. To survive in such an environment, the Phantom Hawk would rely on cutting-edge radar-absorbing materials, advanced electronic warfare systems, and an airframe specifically designed to scatter radar signals away from enemy sensors. In theory, this would make the aircraft extremely difficult to detect, track, and engage. Speed remains a critical factor in air combat, and the Phantom Hawk is often imagined as a platform capable of extraordinary performance. Advanced engines utilizing next-generation propulsion technologies could potentially allow the aircraft to achieve speeds far beyond those of current fighters. These engines would provide not only raw speed but also exceptional fuel efficiency and reliability. The ability to travel quickly across vast distances would allow commanders to respond rapidly to emerging threats and project power wherever it is needed. However, future warfare is not solely about speed. Information has become one of the most valuable resources on the battlefield, and the Phantom Hawk would be designed to dominate the information domain. Equipped with powerful sensors capable of detecting aircraft, missiles, ships, and ground targets at incredible distances, the aircraft would act as a flying command center. Sensor fusion technology would combine data from multiple sources into a single, clear picture, allowing pilots to make decisions with unprecedented speed and accuracy. Artificial intelligence would likely play a major role in the Phantom Hawk's operation. Instead of overwhelming pilots with raw data, advanced AI systems could analyze information in real time, identify threats, prioritize targets, and recommend actions. This partnership between human and machine would allow pilots to focus on strategy and decision-making while automated systems handle routine tasks. The result would be faster reaction times and greater battlefield effectiveness. The cockpit of the Phantom Hawk would represent a dramatic evolution from traditional fighter aircraft. Rather than relying on numerous physical instruments and gauges, pilots could interact with sophisticated digital displays and augmented reality systems. A next-generation helmet-mounted display might project critical information directly onto the pilot's visor, ensuring that important data is always visible regardless of where the pilot is looking. Such systems would dramatically improve situational awareness and reduce workload during high-intensity operations. Weapons technology would also be a defining feature of the Phantom Hawk. Future air combat may involve a combination of traditional missiles, directed energy weapons, and advanced electronic attack systems. Internal weapons bays would allow the aircraft to carry a variety of munitions while maintaining its stealth characteristics. Long-range air-to-air missiles could engage enemy aircraft far beyond visual range, while precision-guided strike weapons would enable attacks against ground targets with remarkable accuracy. Some concepts even imagine the Phantom Hawk carrying laser-based defensive systems capable of intercepting incoming missiles. Such technology could fundamentally change the nature of aerial warfare by providing aircraft with a means of actively defending themselves against threats that would otherwise be nearly impossible to avoid. While such systems remain largely experimental today, rapid technological advances suggest they may become more practical in the future. One of the most revolutionary ideas associated with future fighter aircraft is the concept of loyal wingman drones. Rather than operating alone, the Phantom Hawk could coordinate with multiple autonomous drones that fly alongside it. These drones could perform reconnaissance missions, carry additional weapons, jam enemy communications, or even sacrifice themselves to protect the manned aircraft. Working together as a networked team, the Phantom Hawk and its drones would create a powerful force multiplier capable of overwhelming enemy defenses. Electronic warfare would be another critical component of the aircraft's capabilities. In modern conflicts, disrupting enemy sensors and communications can be just as important as destroying physical targets. The Phantom Hawk could carry advanced electronic warfare equipment capable of jamming radar systems, interfering with communications networks, and confusing enemy missile guidance systems. By dominating the electromagnetic spectrum, the aircraft would gain a significant advantage over opposing forces. The future battlefield will likely extend beyond Earth's atmosphere, and some speculative concepts suggest that aircraft like the Phantom Hawk could interact with space-based assets. Satellite communications, navigation systems, reconnaissance platforms, and missile warning networks could all be integrated into the aircraft's operational framework. This level of connectivity would provide pilots with access to vast amounts of information and greatly enhance their effectiveness. Survivability would remain a central design priority. In addition to stealth and electronic warfare systems, the Phantom Hawk could incorporate advanced damage control technologies and self-healing materials. Sensors distributed throughout the aircraft might continuously monitor structural integrity and automatically detect potential problems before they become critical. Such innovations could improve reliability and reduce maintenance requirements while enhancing combat readiness. Range and endurance are also essential factors in modern military operations. Future conflicts may occur across enormous geographic areas, requiring aircraft capable of remaining airborne for extended periods. Advanced fuel systems, efficient engines, and possibly even aerial refueling drones could significantly extend the Phantom Hawk's operational reach. This would allow commanders to maintain a persistent presence in critical regions and respond quickly to emerging situations. Training for pilots operating such an advanced aircraft would likely differ significantly from current methods. Virtual reality and artificial intelligence could create highly realistic training environments where pilots practice complex missions without ever leaving the ground. These systems could simulate countless scenarios, helping pilots develop the skills needed to operate effectively in future combat environments. The strategic impact of an aircraft like the Phantom Hawk would be immense. Nations possessing such technology would gain significant advantages in deterrence, power projection, and military flexibility. Potential adversaries would need to invest heavily in new defensive systems and countermeasures, fueling a continuous cycle of technological competition. Throughout history, advances in military aviation have repeatedly reshaped global security dynamics, and a platform like the Phantom Hawk would likely continue that tradition. Public fascination with futuristic aircraft reflects humanity's enduring interest in innovation and exploration. The Phantom Hawk embodies the belief that technological progress can overcome seemingly impossible challenges. Whether discussing stealth materials, artificial intelligence, advanced propulsion systems, or autonomous drones, the aircraft serves as a vision of what future aerospace engineering might achieve. Many of the technologies associated with the Phantom Hawk are already being researched today. Governments, defense contractors, and academic institutions around the world are investing heavily in next-generation aviation technologies. Artificial intelligence, advanced sensors, directed energy weapons, autonomous systems, and improved propulsion methods are all active areas of development. While a specific aircraft called the Phantom Hawk may not exist, the concepts it represents are influencing real-world research programs. As military planners look toward the future, they must consider threats that are constantly evolving. Advanced missile systems, cyber warfare capabilities, and sophisticated air defenses present significant challenges. Aircraft designed for future conflicts must be adaptable, resilient, and capable of operating effectively in highly contested environments. The Phantom Hawk represents one possible answer to these challenges, combining multiple emerging technologies into a single integrated platform. The aircraft's hypothetical missions could include air superiority operations, precision strikes, intelligence gathering, electronic warfare, strategic deterrence, and support for ground forces. Its flexibility would make it a valuable asset across a wide range of scenarios. Rather than being optimized for a single mission, it would function as a multi-role platform capable of adapting to changing battlefield conditions. Environmental considerations may also influence future aircraft development. Engineers are increasingly exploring ways to improve efficiency and reduce environmental impact without compromising performance. Future propulsion technologies, lightweight materials, and advanced manufacturing techniques could contribute to more sustainable aviation systems while maintaining military effectiveness. The development process for a next-generation fighter would likely involve extensive collaboration among engineers, scientists, military personnel, and industry partners. Thousands of specialists would contribute expertise in areas ranging from aerodynamics and materials science to software development and systems integration. Such projects often require years of research, testing, and refinement before reaching operational status. Despite its fictional origins, the Phantom Hawk captures many of the themes that define the future of military aviation. It represents a convergence of technologies that are transforming how wars are fought and how military forces operate. The increasing importance of information dominance, autonomous systems, and networked warfare suggests that future aircraft will be far more than simply faster or more powerful versions of today's fighters. As technology continues to advance, the line between science fiction and reality often becomes increasingly blurred. Concepts once considered impossible eventually become commonplace. Radar, jet engines, stealth technology, precision-guided weapons, and unmanned aircraft were all revolutionary ideas before becoming integral parts of modern military operations. The Phantom Hawk symbolizes the next step in this ongoing evolution. Whether viewed as a fictional aircraft, a technological vision, or a glimpse into the future of warfare, the F-22 Phantom Hawk remains a fascinating concept. It challenges us to think about what might be possible in the decades ahead and highlights the extraordinary pace of innovation in aerospace technology. From stealth and speed to artificial intelligence and autonomous drones, the aircraft embodies many of the capabilities that could define future air combat. The skies of tomorrow may look very different from those of today. New technologies will continue to reshape military strategy, redefine operational concepts, and create opportunities that previous generations could scarcely imagine. The Phantom Hawk stands as a powerful symbol of that future, a future where advanced technology, human ingenuity, and relentless innovation combine to push the boundaries of what is possible in the world of aviation. Decades. The State Route 71 Blackbird stands as a timeless reminder that with vision, determination, and exceptional engineering, humanity can accomplish feats that once seemed impossible. It remains one of the greatest aircraft ever built, a true icon of aviation whose story will continue to inspire future generations for many years to come.